Everyone. Today I am going to teach you some case study questions in application of trigonometry. A bit different sums. These are very important. So the first sum: air traffic controllers direct the aircrafts and control them. At a given instance, ATC, that is air traffic controllers, find that the angle of elevation of an aeroplane from a point on the ground is 60 degrees. After a flight of 30 seconds, the angle of elevation changes to 30 degrees. The height of the plane remains constant at 3000 root 3 meter. Use the above information to answer the questions below. There are three questions given. Draw a neat labeled figure to show the above situation diagrammatically. Find the distance traveled by the plane in 30 seconds. Third one, what is the speed of the plane in kilometer per hour? Okay. First, you should understand the sum and draw the figure. That is the main thing. Once you draw the figure itself, you will get an idea how to solve it and how to answer the question. Now, there is some aeroplane flying at the height of 3000 root 3 meter. From a point on the ground, the angle of elevation is 60 degrees. This is the first thing you should think. Okay. So now, this is some point on the ground, and there is an aeroplane here at a height of 3000 root 3 meter. So this is 3000 root 3 meter, and I'm going to join this aeroplane. I call it as A. That is the position of the aeroplane. Initially, I call it A. The below point I call B. The point on the ground I call C. Now the angle of elevation is 60 degrees. Okay, is it clear? Now, after a flight of 30 seconds, that is, the aeroplane is flying at the same height it is given, no? The height of the plane remains constant. So it will be at the same height. But we don't know whether it is going in this direction or this direction. How to find it out? After a flight of 30 seconds, the angle of elevation changes to 30 degrees. When the angle of elevation decreases, the plane is going like this, no? Away from the point A. That is what you should first understand. Supposing the angle of elevation increases, this will fly this side. So that is the first thing you have to understand. So now the plane travels some distance and come to this position, that is D, let us take. Now let us extend this line and we will join it here. I will call this E. Now because this is 3000 root 3, this also will be 3000 root 3 meter. Okay. Now if you join this, that is this CD, this angle is now 30 degrees. Let me explain the figure once again. This A is the first or initial position of the plane. Okay. Initial position of the plane. This C is the point of observation. This C is the point of observation. Okay. Now, this D is the second position. That is after a flight of 30 seconds, second position of the plane. So now, the first question is, draw a neat labeled figure, show the above situation diagrammatically. That without that. You can write it also, no? A is the first position, initial position. After 30 seconds, let D be the position of the plane you can write. You can write AB is equal to 3000 root 3. Since the plane is flying at the same height, DE is also 3000 root 3 and the angle of elevation, that is angle ACB, that is 60 degrees, and DCB, that is 30 degrees. Is it clear? So the diagram is the answer to the first subdivision. So we have answered it. Let us move on to the second one. Find the distance traveled by the plane in 30 seconds. See in the figure. This is the initial, this is the final. So AD is the distance traveled by the plane in 30 seconds. From the figure, you know AD will be equal to EB. So if you find EB, that will be equal to AD, and that is the distance traveled by the plane in 30 seconds. Do you understand this? Okay. Now, how are we going to find this AB? Now, as I told you in almost all the sums, you will be getting two right triangles. Here also, you are having one right triangle ABC. You are having another right triangle DEC. Using that only, we are going to find the distance traveled by the plane in 30 seconds. Okay. Let us first consider triangle DEC. Okay. In right triangle DEC, DE by EC, that will be tan 30 degrees, correct? You will get DE by EC, that is equal to tan 30 degrees. What is DE? You know it is 3000 root 3. So 3000 root 3 by EC, that is 1 by root 3. Now you can cross multiply. What will you get now? EC will be equal to 3000 root 3 into root 3, which is equal to 3000 into 3, so 9000 meters. So you got now EC is equal to 9000 meters, right? Now let us take the right triangle. In right triangle ABC, AB by BC, that will be tan 60 degrees. Right? So now you know AB is also 3000 root 3. So 3000 root 3 by BC, that will be equal to root 3. Now again let us cross multiply. So you will get BC is equal to 3000 root 3 divided by root 3. Root 3 goes. So you get 3000 meters. Now look at the figure. In the figure, you know, EB will be equal to EC minus BC, isn't it? So now EC is what? 9000 and BC is 3000. So you get now 6000 meter. If this is 6000, automatically DA is also 6000 meter. So the distance traveled, the distance traveled in 30 seconds is equal to 6000 meters. So the second subdivision we have finished. Is that clear to you? Now we will move on to the third subdivision. Third subdivision is find the speed of the plane in kilometers per hour. Okay. Now you know the formula for speed is distance divided by time. You have studied this in your lower classes itself. Distance is equal to speed into time. Speed is equal to distance by time. Time is equal to distance by speed. So now you know the distance is now 6000 meter. The time is 30 seconds. This is in meter and this is in second. Okay. You can cut one zero and you will get 200. This will be the speed in meters per second, but you want it in kilometers per hour. So this is meter. To convert it into kilometer, I will divide by 1000. Then it is in second. So per hour into 3600. You might be knowing this, you can simplify as 18 by 5 straight away. But anyway, this is the thing. Meter to kilometer, this is seconds to hour. Okay. So now two zeros go. This zero, that zero. So you will be getting here 2 into 360, which is equal to 720 kilometers per hour. This is the speed of the plane. Hope you are clear about this sum. So case study sums, first understand, read the sum twice, thrice. Then you draw the figure and then automatically from one subdivision to another you can pause on. Now let us see another sum which is a bit different from this. Okay. The second sum, an eagle sitting on a tree of height 90 meter observes a rat on the ground at an angle of depression of 45 degrees. The rat moves away from the tree at certain speed. The eagle starts flying 30 degrees downwards and catches the rat in 10 seconds. Based on the information, answer the questions. What is the horizontal distance between the tree and the rat? Find the distance traveled by the rat in 10 seconds and the eagle in 10 seconds. Third one, find the speed of the rat and speed of the eagle. This sum is also something to do with speed, distance, and all. But here there is a tree, and on top of it, an eagle is sitting. Okay. So now let us have this as our tree. Okay. I will call this A, I will call this B. So here is the eagle sitting. This line I will draw. Now the rat is on the ground. Let this be the position of the rat. Okay, the rat is here now. So the eagle means I have to draw a line of sight there. And it is observing this at an angle of depression of 45 degrees. Okay. Whenever you mark an angle of depression, mark this alternate angle also. Then only you will be able to do the sum. Then what happens? The rat, on seeing the eagle, it starts moving away from the tree. So it is very clear, moving away. So it goes in this direction. Now, but it is just going, okay. But what happens is the eagle flies 30 degrees downwards. That means it starts like this. So this is now 30 degrees and it catches the rat in 10 seconds. So now it catches it at this point D. So at this point, the eagle is catching the rat. It travels for 10 seconds. That's all. It catches the rat. This is the situation given. Any case study question, not will be like a story. They will give some situation and we have to understand it and then go for the sum. So now, this is the thing we know. This tree, the height is given to be 90 meter, that we know. Okay. Now, we have to answer so many questions now. First is what is the horizontal distance between the tree and the rat? That is AC. Because the initial position of the rat is C. So the horizontal distance means it is AC. The next one is the distance traveled by the rat in 10 seconds. That will be CD. Okay. Then the distance traveled by the eagle in 10 seconds. The eagle is here. From there it comes to D. So BD, that will be the distance traveled by the eagle in 10 seconds. If you do all these things, then the speed is easy only. We will use the formula distance divided by time and we can do. So first let us concentrate on the first two subdivisions now. So here I am going to take this, that is, this is the distance traveled by the rat in 10 seconds CD. That I am taking it as x meter. Now here, see this is 45 degrees. So even without working, I know when it is 45, this is 90 means this is going to be 90, isn't it? Straight away. But anyway, let me write one step. That is, I will write in right triangle ABC, AB by AC is equal to tan 45, right? AB by AC is equal to tan 45. So 90 by AC is equal to tan 45 is 1. Cross multiply. So AC is equal to 90 meter. So this is 90 meter. And that is the answer for the first question. So you have to write the horizontal distance between the tree and the rat is 90 meter. Don't stop with AZ. Okay. So write the horizontal distance between the tree and the rat is 90 meter. Okay. Now let me move on to the second subdivision. Second subdivision is the distance traveled by the rat in 10 seconds. This X, that is the distance traveled by the rat in 10 seconds. Let us take the big triangle BAD in right triangle BAD, AB by AD, that will be tan 30 degrees. Okay, since that is 30, this is going to be 30. So now you will get AB by AD is equal to tan 30. So now AB, you know it is 90. AD we want to find tan 30 is 1 by root 3. Cross multiply now. You will get AD is equal to 90 root 3. Okay. So now AD is 90 root 3. You know AC is 90. We want CD. So CD will be equal to AD minus AC. So you will get 90 root 3 minus 90, which is 90 into root 3 minus 1 meter. You can leave it like this. If I give you the value of root 3 as 1.73 or 1.732, put it there and do the calculation. Now I am leaving it like that. So one part of the second subdivision, that is the distance traveled by the rat in 10 seconds, that I have found out, and that is 90 into root 3 minus 1 meter. Okay, let us move on to the next part now. In the second subdivision itself, we have only found the distance traveled by the rat in 10 seconds. Now let us find the distance traveled by the eagle in 10 seconds. I told you the eagle is here. From there, it is coming to D. So we want BD. That is the distance traveled by the eagle in 10 seconds. So now, in right triangle A, B, D. Okay. A, B, D. You know A, D. Sorry. A, B. A, B only we know. So I am taking A, B by B, D. That will be sine 30 degrees. Isn't it? Opposite side by hypotenuse. A, B by B, D. That will be sine 30 degrees. So now AB is 90 by BD sine 30, you know that is 1 by 2. Cross multiply, you will get BD is equal to 180 meter. This is the distance traveled by the eagle in 10 seconds. Is it clear? So this is the distance traveled by the rat in 10 seconds. This is the distance traveled by the eagle in 10 seconds. Okay. So now let us come to the third subdivision. Find the speed of the rat. Find the speed of the eagle. You know the general formula? Speed is equal to distance by time. So now, speed of the rat. What is the distance traveled by the rat now in 10 seconds? That is 90 into root 3 minus 1 divided by 10. Okay. So this 0 goes. You will get 9 into root 3 minus 1 meters per second. This is the speed of the rat. Coming to the speed of the eagle, speed of the eagle. What is the distance traveled by the eagle? 180 meter in 10 seconds. 0 goes. So it is 18 meter per second. Is this sum clear to you? See, the case study sums, it may appear first not to be difficult, but once you understand the sum and the situation and draw the figure correctly, then it will be easy only. So one more sum, which is also a bit different in that they have themselves given the figure, but it will be a bit new to you. So let us do that also now. Okay. Third sum. A drawbridge is 60 meters long when stretched across a river. As shown in the figure, the two sections of the bridge can be rotated upward through an angle of 30 degrees. If the water level is 5 meters below the closed bridge, find the height h between the end of a section and the water level when the bridge is fully open. How far apart are the ends of the two sections when the bridge is fully open? You have to understand the figure clearly. Actually, I have only named it. They haven't named it in the figure given. In case they don't give you a figure also, you should first understand how to draw the figure. Okay. So here, this is the water level down and the upper one I have taken the upper limit as AB. That is the water level. Okay. Now, this CD is when the bridge is fully closed. There are actually two sections. No, this section as well as this section is divided into two sections. So this is 30 meter. That is 30 meter. That is what I have written as 30 meter half part. Not this one. I mean this one. Okay. Up to this is 30 and this is 30. Now the bridge is such that this portion, I think I can name it as some, yes, CS and SD, let us take. The CS you can open and that becomes CE, and that SD can open and that becomes that DF. They can be rotated at an angle of 30 degrees. So here, this is 30 as well as this is 30. That is given. Okay. So now the CE and DF are the position when the two sections are fully open. CS and SD are the bridge when it is fully closed. Okay. Now it is given this is 60 meter. That is the CD is 60. So the half is 30. So that half only is this one. So that is 30. That is 30. Is it clear? Now I have named this CP as some X. Similarly, here the QD is X and this EP is Y and FQ is Y I have named. They have given this distance, that is the height between when the bridge is closed and the water level is 5 meters. So this portion is 5 meters. Is the figure clear? Now, the first question is If the water level is 5 meter below the closed bridge, find H. What is H? Between the end of a section, that is either CE or DF, and the water level when the bridge is fully open. Now let us consider one side. Now the bridge is fully open. So from E to R, that is what you want to find. The distance between the one end and the water level. You want CR. So if you find EP and plus the 5 meter, if you add, you will be getting that ER. That is what we want for the first subdivision. So now in triangle, I am considering this triangle CEP. Okay, in triangle CEP. Now I am going to find out this part. So I take EP by CE. EP by CE, that is opposite side, by hypotenuse. What is it? That is sine theta. So that is equal to sine 30 degrees. EP, we have taken it as y by CE is 30, that is equal to 1 by 2. So y will be 30 by 2, that is 15 meter. So this distance EP, that will be 15 meter. Okay. Now, the first question is you want H. H is equal to y plus 5. This 5 meter also you have to add. So 15 plus 5, that is equal to 20 meter. This is the answer for the first subdivision. Do you understand? The second one is how far apart are the ends of the two sections. This is one end, this is another end. We want this EF now. The EF will be equal to PQ, isn't it? EF will be equal to PQ. Now you know this full is 60. Okay. From that, this is 1x, that is 1x. If I subtract, I will be getting PQ. So now, for the second one, the bridge is fully open. The distance between the ends, that will be 60 minus 2x. So let me find out x first. What is x? I can take the same triangle. I will get x by 30, that will be equal to cos 30 degrees. Isn't it? What is cos 30? 30 degrees, that will be root 3 by 2. So you will get that is equal to root 3 by 2. So x will be 30 root 3 by 2. So you will get 15 root 3. Okay. So that is 15 root 3. That is your x. So here the distance is 60 minus 2x. So it is 60 minus 2 into 15 root 3 is 30 root 3. So this is the thing. You can substitute 3 is equal to either 1.73 or 1.732 and you can get the value. So that will be the distance between the two ends when the bridge is fully open. So hope that the three sums which are a bit different from what we have done in the last one is clear to you. So, in the trigonometry and application of trigonometry has a weightage in your board exam for 12 marks. So, definitely from the heights and distances, you will either get a case study sum or some 4-mark sum you can get. So, you should be thorough with both. Then we have done the MCQs also in the first video. Then we have done identities which can come for a 2-mark or 3-mark. So, we have completely somewhat covered. If you have any doubt still in the trigonometry sums, in application of trigonometry also, don't hesitate to write either in the comment section or already I have told you, you can always contact me in my WhatsApp number and wherever you are, whichever school you are. So you can write your doubts in this number. You can introduce yourself, your name and the school and where you are, which city you are, And for this number, if you message, surely I will answer your doubts. I will clear it. Okay. So the trigonometry is over. So let us see some other chapter in the next video. Thanks for watching. Like, comment, and share. Thank you.